All right, so the next thing we're going to talk about is square roots and simplifying radicals. So when I see that square root symbol, what I really want to note is that I'm trying to figure out what things multiply to it. So if I took the square root of 100, the answer would be 10 because 10 times 10, or 10 squared, is 100. But when the numbers aren't nice, we have some other options. So you may have seen this a few different ways. One way you might have done a factor tree and listed out the prime factorization. And that's totally an option. Nothing wrong with that. A little bit quicker, if you know your numbers well enough, would be to think about what can you divide the number you're seeing, what perfect square goes into it. So what's something you can take the square root of that you can divide the number you see by. So for example, if we take a look at example 1, I see the number 75. I know the number 25 has a nice pretty square root answer. So 25 times 3 is 75. So instead of doing the prime factorization, I can really just split this up into 25 times 3. And then I have times x squared times y squared. You don't have to do it this way, but to me, it's a little bit less time consuming. So if we do this, the square root of 25 is 5. So this guy I'm taking the square root of and getting 5. I can't take the square root of 3, so I'm going to leave that guy behind. The square root of x squared is x. Technically, that should be an absolute value because we went from even to odd. An even exponent of 2 now to an odd exponent of 1. And y squared is also same idea, is going to be y. So those two should be an absolute value. You may or may not have talked about that last year. Not a huge deal if you didn't. And then the square root of 3 is left behind. So these guys I took the radical of, but I can't take the square root of 3. All right, so if we take a look at example 2, we can use the product property rule that says if I have two radicals, I can multiply the radicand, the insides, together. So I can say the square root of 15 times the square root of 5 is the square root of 15 times 5. Well, 15 times 5, I believe, is 75. So the square root of 75, now I can say, okay, what's going to multiply, what's going to multiply to 75 that has a perfect square? The same as before, we can use 25 times 3. So the square root of 25 is 5, and I have the radical 3 left on the inside. All right, lastly, we have the square root of 3 over the square root of 2. Now, I can think of that as the square root of 3 divided by 2, but that doesn't really help me in this case. What I do want to keep in mind is square roots should not be left in the denominator, and that's called rationalizing the denominator. In order to fix that, what we're going to do is multiply by really just that denominator over itself. So really I'm multiplying by 1, something over itself. But by doing this, it's going to get rid of the square root down there. So on top, square root of 3 times the square root of 2 is the square root of 3 times 2, or 6. On the bottom, that's the square root of 2 times the square root of 2, or the square root of 2 times 2, which is 4. And we know that the square root of 4 is the number 2. So I get the square root of 6 over the number 2. The square root is only over that numerator.